All right, in this video, we're going to learn how to construct the circumscribed circle. So remember, the circumscribed circle goes on the outside of the triangle, and it's technically the smallest circle that we can fit that will pass through, well, the only circle around the outside that will pass through all vertices, all three vertices of the triangle. It's the smallest circle outside the triangle. Okay, so we're going to construct it. In order to construct the circumscribed circle, we have to be able to find the circumcenter of the triangle. And we've talked about this word before. It's the center of this circumscribed circle. So it's the radius of that circle comes from the circumcenter. That's the point we're looking for. The circumcenter is one of 4 points of concurrency, they're called. So there are these major points inside triangles, points of concurrency. It's one of 4, but what it means to be concurrent is this. Lines are concurrent if, and it takes more than 2, because any 2 lines intersect eventually unless they're parallel. That's not all that special. But by the time you add a 3rd line, now if they're all 3 intersecting at the same point, these lines are said to be concurrent. If we have a 4th and a 5th, they're concurrent if they intersect at the same point. It takes 3 or more lines. So the circumcenter is a point of concurrency, so it must be the intersection of 3 or more lines. So what we're going to do is find the circumcenter of a triangle, and then we'll come up with our circumscribed circle. So the first thing we need is a triangle. And in theory, we all should be able to just pause the video, draw a triangle, and then turn it back on, and we should all have different triangles. And the characteristics of the circumcenter are going to be the same no matter what kind of triangle we make. But maybe for the purpose of this video, we should all kind of have a similar triangle, not literally similar, but triangles that pretty much look the same so that we can follow the steps of the construction. So I'm gonna make my triangle. I have this plain blank paper. I don't want it to be too close to the edge because remember, I've got to fit a circle around the outside of it, but I also don't want it to be so small that the construction is difficult. But I'm just gonna go ahead and make a triangle. I think I'm gonna go with like a scalene looking triangle. Looks like it's an obtuse triangle. This angle's a little greater than 90 up there. Anyway, here's our triangle. All right, the circumcenter is formed by the 3 perpendicular bisectors of the sides of the triangle. So we need to construct perpendicular bisectors. And I'm going to start with this bottom side, the longest side. So remember, to construct a perpendicular bisector, you need your compass open greater than half the length of the segment, and you're going to swing arcs above and below the segment from each of the 2 endpoints. So from each endpoint above and below. And where they intersect, this is going to be these are our points that we're going to use in order to draw the perpendicular bisector. So line your ruler up and go ahead and draw 1 of 3. So there it is. I bisected this side. Now I need to bisect this little side of the triangle, and it might just be easiest to keep track of what you're doing if you always just kind of spin it so that you're working off the side that's at the bottom that looks like the horizontal. All right, my compass only needs to be open greater than half. I don't really want to get carried away here, so I'm going to choke it down a little bit, and I'm going to swing arcs from either endpoint above and below the line. From either endpoint above and below the line. Okay, here's my next perpendicular bisector. Now, here's what I want you to remember. These lines are concurrent. All 3 of these lines are going to intersect one another, and that's where our circumcenter is going to be located. So if I only draw my perpendicular bisector like such, sure enough, it's perpendicular to the side. I can see my right angle. And it did split this side into 2 equal pieces. But if I only draw it like such, I'm never going to find the circumcenter, because the circumcenter is where all 3 of these perpendicular bisectors intersect. So if these lines are indeed concurrent, I should have already found the circumcenter, but we need to do one more side. So I bisected the bottom side, I bisected the left side, now I need to bisect the right side. I'm gonna go ahead and spin it around again though. So this is the side we're working off of. All right, opening the compass greater than half, swinging arcs above and below from either of the two endpoints. Okay. All right, and then our final perpendicular bisector, we're gonna swing it through these 2 points right here. And you can already see, I think, that it's gonna pass right through the point that we had a moment ago. So they were concurrent. They all intersected at the same point. And this point right here is the circumcenter. All right, here's another important characteristic about our circumcenter. Our circumcenter is equidistant from, if it's the center of the circle and this circle passes through those 3 vertices, then it has to be equidistant from the 3 vertices of the triangle. So that is how we're gonna find our radius of the circum circle. So we're gonna take our compass and we're gonna open it up from the center to one of those vertices and check it. It should be the same distance to the second vertex and the same distance to the third vertex, and it is. So we can go ahead now and just carefully construct our circle. And there you go. Okay, so that circle is outside the triangle. It's passing through all 3 vertices of the triangle. This is called the Circum Circle, and we found the circumcenter, and the circumcenter was the intersection of the 3 perpendicular bisectors. It's the first of our 4 points of concurrency.